How do you evaluate the impact of one variable upon another in a given data set? Today, we are going to go over all the code needed to understand how to do simple linear regression in Python. My name is Jacob from Intrepid Protoworks. So I decided to do a couple of videos on linear regression. This first one will just be simple linear regression. There are lots of great programs out there that can do linear regression just fine. Some of the pleasantries of using it with Python is that you can bake your analysis into whatever other code you are writing, and it's completely free, so low barrier to entry. We're going to start off by doing some imports. We're importing CSV so we can read the data. We're importing random so we can simulate a data set. And we are importing matplotlib.pyplot as PLT, and then we're using plt.style.use.bmh, and that's just my own preference. There's a bunch of styles out there. I've gone over them in previous videos. So we're going to define simple linear regression. We're going to define a whole bunch of empty variables here. Some x equals 0, some y equals 0, some xy equals 0, some x squared equals 0, some y squared equals 0, and the number of measurements will be equal to the length of our data set. Unlike previous videos with the ANOVA, we're just doing a simple list to represent our data set rather than a dictionary like we have done in our other ANOVA videos. We will then define an empty list called x, make some space, and start our for loop to fill all these empty variables. We will then say for row and data, x.append row 0, sum x plus equals row 0, sum y plus equals row 1, sum x y plus equals row 0 times row 1, sum x squared plus equals row 0 squared, sum y squared plus equals row 1 squared, and then we can go ahead and back out of our loop. So I'll put in a couple comments. Y equals b plus mx, so the standard linear line function. M is going to be our slope, and then we'll go ahead and define a couple of variables. X min is going to be the min of the x list we did. X max is the max of the x list we did. Now let's go ahead and calculate our slope. We're going to go ahead and flesh out the structure of this. So we're going to have one term divided by another term, and then within each of those terms will be one thing subtracted by another thing. And then we can go ahead and fill those in here in a moment. Additionally, we're going to go ahead and do the same thing for the intercept. So starting with the top term of our slope, we will go ahead and do the sum or the number of measurements times the sum of xy minus the sum of x times the sum of y, all that divided by the number of measurements times the sum of x squared minus the sum of x times the sum of x. Then for the intercept, it will be the sum of x squared times the sum of y minus the sum of xy, all divided by the number of measurements times the sum of x squared times the sum of x. So go ahead and make ourselves some more space and then start calculating our r squared. We go ahead and do the same thing where we look at one term divided by another term, and then we'll fill in what goes into these. So our r squared is a measure of how much variance is accounted for by the line that we are calculating. We'll get this by taking the number of measurements times the sum of x times y minus the sum of x times the sum of y squared, and then divide that by the number of measurements times the sum of x squared times the sum of x, or minus the sum of x times sum of x. And then all of that will be multiplied by the number of measurements times the sum of y squared minus the sum of y times the sum of y. We now have all the main information needed for our simple linear regression. So let's go ahead and also give ourselves a line to plot. So we'll say min calc y is equal to the intercept plus the slope times the min x. And we'll say max calc y is equal to the intercept plus the slope times x max. The regression line will then be 2 points. It'll be x min and min calc y, and x max times max calc y. We'll then go ahead and return the regression line, the r squared, the slope, and the intercept. With that in place, we can now go ahead and move on to our example. This time, our data set will just be put into a simple list called Dataset. We'll do our standard with open data equals csv.reader for row and data. We'll filter out the row. We'll filter out NA applies, which is that 7 nines. We'll say if they make more than 5,000 and less than 200,000, and we'll look at people between the ages of 18 and 64. So in other words, adulthood to retirement. Then we can go ahead and append to our data set their age, and their income. And this will be our example data set for today. To look at a data set that is more appropriately sized to what a lot of the watchers of this video might want, we're going to go ahead and just sample out of that data set of around 3 million. We'll set the number of subjects as equal to 50, and then we'll say our data sample is equal to random.sample. We'll take it from our data set, and the amount will be the number of subjects. We will then go ahead and grab our outputs, and then we will set our outputs as equal to simple linear regression of our data sample. And then we'll go ahead and set up a few print statements that will show us a formatted output. With some basic output out of the way, we can go ahead and move on to our last part, which will be a graph that will give us a scatter plot and also our regression line. So we'll define an empty list called XRL or X regression line and YRL or Y regression line, and then X and Y. We'll say for row in regression line, and then we'll just append the first element to the XRL and the second element to YRL. And then we'll go for row in data sample, and then do X append our first element and Y append our second element. This will give us 4 lists, one that can be used to plot our regression line and one that can be used as a scatter plot for our graph. Go ahead and define X min as the min value of X, and we'll say Y max is the max value of Y. We'll use that for where we place our text box in our scatter plot. We'll do plt.plot XRL YRL, and we'll do plt.scatter X and Y. And now we'll go ahead and define our text box. This will be the most involved part of it actually, and also kind of optional. So first we'll define some characteristics of a box, and we'll call it props. We'll say define it in a dict. We'll say our box style is round, so I have rounded edges. The color of our box will be gray, and it'll be a little bit transparent with an alpha of 0.5. Then we'll do plt.text. Our locations will be at the X min and the Y max. That'll put it in the upper left corner. The text will be our R squared plus the string of, we'll convert the R squared value to a string, and then our font size will be 14. That should be big enough to see. We'll justify the box, the text in the box towards the top, and the properties of the box will be box equals props. We'll go ahead and give it an X label, a Y label, and a title, and then we'll do plt.show. With all our code in place, we'll set to run a new dedicated Python console, and then save and run and look for whatever typos we have. So, we did not make that a comment. So m equals slope should have been a comment. Run that again. And we have a couple of things that look wrong. We're not seeing our regression line, and our R squared looks funny. So let's look through go for our graph real quick. Not seeing anything immediately wrong with our graph, so let's go ahead and look up at our function up top. What I'm looking at, let's go ahead and round our R squared value to 4 decimal places. We don't really need to look at 10 decimal places. I'm picking through our slope, intercept, and R squared calculations to check that they're correct. Next, I'm looking through, see if there's any typos in the min calc Y and max calc Y and the regression line, as well as the returns. Let's scroll back down and take a look through all of the stuff down at the bottom, our output as well as our graph. Let's go ahead and save and run one more time to see if the issue repeats itself. Yeah, so we see a strange R squared value as well as our regression line not showing up. Let's look back at our regression function and reference our notes real quick. So I'll paste that in and check if anything's different, as I'm still not seeing where the typo is. I'm sure you guys are seeing it and cringing right now. Do note that the working code will be on the GitHub. After looking at it for a little bit, we can see that the issue is that things are actually not indented correctly, never actually exited out of the for loop. So we need to go ahead and move the X min, X max, the slope, the intercept, the R squared, all that stuff, all down one indentation. After looking at the R squared for a little bit, I see the issue is that we did not properly put brackets around the last terms. Let's go ahead and fix a typo down here real quick, and then take one last look at our code and try running again. There we go. We should have it now. Looks like everything makes sense. Our R squared is pretty small. You can see that age is not necessarily a great predictor of income. Take for that what you will. At least in our example, we can look at it in much better ways. And in a future look at regression, we will go ahead and examine a significance test for our linear regression model, as well as adding in additional factors to see if we can account for additional variability with a more complex model. If you see any issues with the code, or if you have any comments or questions, please post them down below. Again, the code is available on the GitHub site. Thank you for watching, and don't forget to like and subscribe.